All right, everyone. So this is going to be your last lesson for the quadmester. So we're just going to end off with solving problems involving rates of change. So we talked about this in the polynomial unit, local maxes and mins. Remember, this only happens with odd degree polynomials. So as you can see over here is a local max, and over here is a local min, because they are not the absolute highest or lowest points on that graph. Okay. So in some graphs, a point could be both a local max or min. So in this case, this is a local max, but also an absolute maximum. And over here, this is a local min, but it can also be a absolute min. So this is local slash absolute min. And then this is a local slash absolute max. However, this one over here is just an absolute max, because it is the highest point on the graph. So we're going to have a few examples, and then that's probably it for today. So a theater company profits Px in dollars is described by the equation P of x is equal to negative 60x squared plus 1800x plus 16,500, where x is the cost of a ticket in dollars. And we need to figure out what price will give us the maximum profit. So we're going to have to put this in vertex form. So in the form of P of x is equal to a bracket x minus h squared plus c. So we need to start off by factoring. So we have P of x is equal to negative 60 x squared minus 30x plus 16,500. Remember, when we're completing the square, we're only focusing on the first two terms, and that is what we factor out, and then this is left alone. Okay? So hopefully you guys remember completing the square from grade 11. And then all we have to do is expand, so we get negative 60 times x squared minus 30x plus 225 minus 225 plus 16,500. Remember, these values you get from taking 30, dividing it by 2, which is equal to 15, and then squaring that value, which gives us 225. So then we are left with negative 60 bracket x minus 15 squared. And now this number, negative 225, we need to multiply by our a value, which is negative 60. So it gives us plus 13,500 plus 16,500. And then we are left with negative 60 times x minus 15 squared plus 30,000. So our vertex is 15 and 30,000, which means that the cost of the ticket should be $15 to get maximum profit. Okay, now we want to do the same thing. So we want to calculate the average rate of change in profits for various intervals near the x value found. Okay, so we know our x value is equal to 15. So we are going to take a preceding interval close to 15 to figure out the average rate of change. So we'll take x is between 15 and 14.9. So remember, 14.9 is to the left of 15. Which means our average rate of change is f at 15 minus f at 14.9, and this gives us 0.6. Our change in x is 15 minus 14.9, which is equal to 0.1, and delta p over delta x gives us 6. And then we have to do the same thing Let's pick an interval smaller, so x less than or equal to 15, but less than or equal to 14.99. We get our p of x is, our change in p is 0.06. Our change in x is 0.001. And our average rate of change is 0.6. Which means that these rates of change have a positive correlation. So if we look at the graph or at the equation, we have a negative a value, which means our graph is going to open down, which means we're going to have a downwards parabola. So what this means in the preceding interval means that the tangent approaching 15 from the left-hand side is going to be positive, okay? And now we're going to see what happens when we approach it from the right side. So the following interval, something that comes after 15, we're going to do the same thing. So our change in p of x is going to be negative 0.6, and our change in x is going to be 0.1, and our average rate of change is going to be negative 6. And now we pick a smaller interval, so 15.01 greater than or equal to 15. It's the same idea, except the changes in x and p of x are negative. So as you can see, these rates of changes are negative, which means that the slope of the tangent on the other side of the vertex is going to be negative. So we want to use the results in B to estimate the instantaneous rate of change. So we just have to take the average of both slopes that we found. So we have a slope of 0.6 plus negative 0.6 divided by 2 is equal to 0, which makes sense because if we were to average out the slopes, this x value should give us a slope of 0 because it is resting at that maximum point. And over here, we can see that reflects exactly that. So at this point, the tangent line would be a horizontal line. So like I said, if we draw the graph out, we get a downwards parabola. So as you can see, if we're approaching to the left, all these tangents are going to be positive. If we approach right going down, these are all going to be negative. So if you were to average them out, you would be able to get the slope of the tangent, which is always going to be 0. So slope of tangent at vertex is always 0. So,
We're beginning of class.
so here we have some just general information. So the instantaneous rate of change is always 0 at both a maximum and minimum points. Graphically, the tangent lines are drawn horizontally at these places. okay? So as you can see as the local max and mins, they're always horizontal lines represented by tangents. So the tangent lines must have a negative slope before the minimum point occurs and a positive slope after, which makes sense because if you're coming down, you have a negative rate of change, and when you come back up, your rate of change is positive. So tangent lines must also have a positive slope before the max and a negative slope after. So the next example is for the function f of x is equal to negative 3x squared plus 24x minus 45. We want to verify that the maximum occurs at x is equal to negative 4, and we want to use the difference quotient. So our average rate of change is equal to f at 4 plus h minus f at 4 divided by h. Now we just sub in our equations. So we get negative 3, 4 plus h squared plus 24 times 4 plus h minus 45 minus negative 3 times 4 squared plus 24 times 4 minus 45. And this is all divided by h. And then once we simplify everything, we are left with negative 3h squared over h, which is equal to negative 3h. So now we have to figure out the average rate of change at positive 0.01 and at negative 0.01. So as you can see, this makes sense, okay? Because 0.01 is to the right of positive 4, it has to be a negative because we want a maximum, and the point before 0.04, which is represented by negative 0.01, is positive, which means that our graph is going to have a max at x is equal to 4, which means that the instantaneous rate of change is 0.03 plus negative 0.03 divided by 2, which gives us 0. Okay, which means that at x is equal to 4, we do have a maximum value. And then our last question is the cost of running an assembly line can be modeled by the function c of x is equal to 0.3x squared minus 0.9x plus 1.675, where c of x is the cost per hour in thousands of dollars and x is the number of items produced per hour in thousands. The most economical production occurs when 1,500 items are produced. Verify using the appropriate calculations for the rate of change in costs. So because it's in thousands, we need to take 1,500 and divide it by 1,000, which gives us 1.5. So this is going to be the x value we are going to be looking at. So what we can do is do the preceding and following. And following interval method. So we're going to be looking for preceding, which is before. X is less than or equal to 1.5, but greater than or equal to 1.49. So our average rate of change would equal to c at 1.5 minus c at 1.49 divided by 1.5 minus 1.49, and we get that to be negative 0.003. Which means that the slope before max slash min is negative because we got a negative result. So now we're going to use the following interval. So x is less than or equal to 1.51, greater than or equal to 1.5. So we're going to do the same thing. ARC is equal to c at 1.51 minus c at 1.5 divided by 1.51 minus 1.5. And that gives us a slope of 0.003. which means that the slope after max/min is positive. So now to calculate the instantaneous rate of change, we take the average of both slopes. So 0.003 plus negative 0.003 divided by 2 gives us 0. So since the slope to the left of the x value we're looking for is negative, and the slope after the maximum is positive, it is safe to assume that this is a minimum, and we have a parabola opening up, and our vertex is at x is equal to 1.5. So that's pretty much it for this course. Hopefully you guys take a look at this video. Like I said, it was awesome teaching you guys. You guys are a good group of kids. And hopefully we get to see each other at graduation. But other than that, good luck in Quadmaster 3 and in your second semester courses. And hopefully you guys got accepted into some universities already.